Hi everyone, welcome to another tutorial video. In our today's video, I will go over how to convert a raster file into a shapefile by using Python. So let's get started. So in order to do this, I'm gonna use Jupyter Notebook. So I already created a folder called raster to shapefile, and inside of this folder, so you can see. So let's go to this folder. So you can see over here that this folder contains a folder that storage the raster file, which is the New Jersey land use land cover dataset as a raster. So and our goal is to convert this file into a shapefile by using Python. So the first thing that we need to do is create a Jupyter notebook. I'm gonna name it as a raster to shapefile. Perfect. So the first thing that we need to do is specify the location of the folder where is located this specific Jupyter notebook. So escape enter to hash. Let's create a title, location of the folder. By the way, you can run a cell by using this button over here, run, or shift enter. Okay, so OS CHDIR, and inside the parentheses, so let's specify the location. So in order to like avoid some errors, I usually put the R before putting the location, just to avoid some problems. Okay, so over here, so this will be the location of the folder of the the Jupyter notebook. Shift enter. So now let's open the raster. So reading the raster file. So I'm gonna use several several libraries from a package called OSGeo. So I'm gonna import Gdal, OGR, and OSR. So now I'm gonna create this variable called raster, and I'm going to read and storage the raster into that variable. So Gdal open. By the way, in order to do this conversion to the raster file into a shapefile, so I'm gonna use the yes, as I mentioned before, these three packages. The most popular one is Gdal. So over here, I'm gonna specify the location of the TIFF, which is the raster file, and it's located in this folder, and it has the same name, following by that TIF. Perfect. So if you try to read this raster, so you will get this. However, you can with Gdal, so you need to use some function in order to get some parameters of the raster. For example, if you want to get the band, so you can use raster. So you call the raster, and you can use the function called get raster band, and you need to specify which band. In this part, for this particular raster, it just storage one band, which is the line use land cover dataset, and those are integers. So a specific integer represent a specific class of the line use land cover. So as I mentioned, it just contains one band. And if I try to read, so you can, as you can see, you cannot see the matrix, the array. However, if I put band and use the function read as array, So now you will be able to look at the whole array. So by the way, zeros are, there is no particular class for zero, so it's like a non-value, a non-value. So perfect. So let's get straightforward to and convert this raster into a shapefile. So I'm gonna create a new title. So converting raster to shapefile. And over here, so we are going to use a function from Gdal called Polygonize. This is a common function that you can find in QGIS. But before using that function, so we need to do several things before. So the first thing is we need to specify the projection that we are gonna put to the new shapefile that we are gonna create. So so we are going to, I'm gonna call this proj variable to storage the projection that the raster has it. So get projection. Perfect. So I basically storage the projection of the raster. And now I'm gonna create this variable called shapefile projection. And I'm gonna use OSR library, the package. I'm gonna call a special reference function, and over here, so I'm gonna storage the spatial reference that has the raster by using import from well-known projection, so WKT and over here I'm gonna put the projection. So this variable over here is this one is the same. So basically I'm saying that the new shapefile that I'm gonna create, it will have it's gonna have the same projection that the raster has it. So now what I'm gonna do is I'm gonna create an empty shapefile which I'm gonna use later to storage all the data that are inside the raster. So I'm gonna call it as an output file. With these variables, I'm gonna basically put the location of the shapefile that I'm gonna create. So I'm gonna create a new folder, and over here I'm gonna name it as a output shape file. So inside of this folder I'm gonna storage the shapefile. So I'm gonna put the location over here. So this is the folder, and we'll have the file will have the same name as the folder. Perfect. So now I need to specify the type of the file. I'm gonna call it as a call drive. So I need to specify which file I'm gonna create. So with this function called get driver by name, I'm gonna specify the type of file. In this case, it's an S3 shapefile. Oops. Perfect. So now I'm gonna create this empty shapefile. So shapefile. So now I'm gonna call drive variable, and I'm gonna use a function called create data source, and I'm gonna select the location of the so with these two lines I'm basically creating the shapefile and saying and telling to Python the location of that I'm gonna use to save the shapefile. So now I need to create a layer in the shapefile that I just created. Create. So I'm gonna use the function create layer, and over here I need to specify the name of the layer. So I'm gonna use I'm gonna put layer name, whatever name you want to put it, and the SRS will be the spatial, basically the projection, the spatial reference that we are going to assign to this specific raster, and this will be basically this variable that we already put it over here, shapefile projection. So perfect. So so now we need to create a new field. So new field, and over here OGR field. So let's define the field. So basically we are going to in a shapefile, so we are going to create a column called ID, and inside of that specific column, so I'm going to store each of the values of each of the polygons. So in the values in the column, so each of the values will represent a specific number that represent a specific class of the line use line cover. So therefore this specific number, as you can see, is an integer. So I need to specify that it will be an integer by using OFT integer. And now, so let's call the shapefile layer, and I need to, now that I define the field and I put the properties, all the details, so I need to create a field by using all the criteria that I just put. And now we're gonna use a function called Gdal, this Polygonize function from Gdal, and in order to convert the raster into a shapefile. So if we go to Google and put like Gdal.Polygonize, we enter to the second link, and over here we've looked for Polygonize function. So you can see that this function takes some parameters. I'm gonna put this link in the description as well. The first one is we need to specify the raster band. So the raster band will be this over here, this variable that we storage, so band, comma. The second variable will be the mask. So if you want to like clip or just get a part of the raster, so you can do it by basically putting a mask, a band that contains a mask. I don't have a mask. I just want to convert the whole raster to a shapefile. Then we need to specify the shapefile location. So basically, sorry, the shapefile that we're gonna use to storage the data should be is HP layer. Then we need to, there are several other parameters. This is basically to get the all the information. So I'm gonna put zeros. And the last one is so the callbacks. So I don't want to use the callback for reporting the algorithm process. So I'm gonna just put callback equals none. And over here, I skip a variable over here, which is an empty list. And as you can see, so which is this one over here, so it's a name value list of additional option. So you can see one of the option over here. I don't have any additional options, so I need to put like an empty list. But if you have like additional options, so you can put it inside of this list, the square brackets. So to finalize, we need to basically close the shapefile that we use to storage the data by using chp destroy, and the raster, so we need to empty that variable. So now if I run this, so you can see if we go to the folder that we created and I refresh, so every single time that I refresh, so you can see that the size of the shapefile is increasing. So yeah, so you can see over here that is working on Python. So let's wait. Perfect. So it just finalized. If we go, so you can see the final size. Let me refresh again. Yeah, the final size is 363,000, almost 700 kilobytes. So perfect. So we got the shapefile. So now we can so let's read the shapefile just to make sure that everything is working. I'm gonna use a common library which is called Geopandas in order to read the shapefile. So should be line use line cover gpd Geopandas by using the function read file, so I can read the shapefile inside of the parentheses. So we need to specify the location. So I'm just going to copy paste this variable over here, and as you can see, it basically is gonna take some time, and it actually depends on the size of the raster. So basically this 36 megabytes is the size of this raster. So you can imagine that if you have like if the size of your raster is like a 1 gigabyte, it will take like a lot of time to read and also to convert the raster to a shapefile. So in the meantime, I'm gonna put a code over here. So I'm gonna call the variable that stores the shapefile, and I'm gonna print the first 5 rows. Um, so you can see over here that basically um, with this function, so you basically print the first 5 rows. You can see that the first column is called ID, which is a column that we created, and inside of this column is a specific value which represent a specific class for a line use line cover dataset, and it's an integer value. And this basically, if you are working with shapefiles, either points or polygons, so the last column of a shapefile, if you read the shapefile in Python, will be geometry, which will storage the polygons or points or multi-polygons, depend on the shape that you are using. But yeah, so then use line cover. If I just put the variables, so you can see all the values. They're almost like almost 1.7 million, 1.6 million values. And yeah, that's it for our today video. Don't forget to subscribe to the channel and hit the like button.